Section 12.5, use recursive rules with sequences and functions. All right, so what we've used so far has been called an explicit rule. An explicit rule takes each term and describes it as a function of its position in the sequence. So what we've done is we've said, well, the fifth sequence, we're going to use this same function, this same equation to represent it as we did with the fourth. We just plug in the 4 instead of, or the 5 instead of the 4. All right. A recursive rule relates the terms to each other. So it says, and a lot of you tried to do it this way, tried to use recursive rules when we were first starting this, starting working with sequences. It's easy to see how one term relates to each other, how one term relates to the one before it. All right. And so what we're going to do is we're going to use the term a sub n minus 1 to indicate the previous term. So n is the term we're on, and so n minus 1 would be the previous term. So what a recursive rule might look like is this. In a recursive rule, we have to be given the initial amount, because remember before, the initial amount was always 1. We always started with 1, and so we knew the first number in a sequence was 1, and so each term was related to its position in that sequence. So now we're going to say the first position is negative 2. So your initial amount is negative 2. And after that, we can use this as a starting point, and our term is going to be the previous term, so a sub n minus 1, the previous term plus 3. So here's how you would evaluate, and this is what we're doing here, evaluate this recursive rule. What we would do is we would say, well, the first term is negative 2, and each subsequent term is going to take the previous term, so negative 2, plus 3. So this value would be 1. And then, so for the third term, we're going to take the previous term, so the 1, and we're going to take it plus 3, which would be 4. And then we're going to take the previous term and add 3 and get 7. We're going to take the previous term and add 3 and get 10. The previous term is 10 and get 13. All right, so you can see, excuse me, this is actually an arithmetic sequence, because what we're doing is we're starting with the previous term and we're adding that common amount. So we're adding 3 to each term. Now in a geometric term, in a geometric rule, what we're going to do is we're still going to start with initial amount, and then we're going to take that initial amount and we're going to multiply it by the rate. All right, so in this case, the initial amount is 32, and my rule is half of the previous amount. So half of 32 is 16, so half of 16 is 8, half of 8 is 4, half of 4 is 2, half of 2 is 1. All right, and so that's how you would evaluate that one. Now, this way is cool in that it's quick and easy to recognize the rule. It's difficult in that you can't just say, well, what's the fifth term? You've got to actually figure out each term in order to get to the fifth term. Whereas with the explicit rule, you could say, well, what's the 20th term? And you could just plug 20 in for n. All right? So now what I want you to do is I'm going to give you the sequence, and I want you to determine what is the rule. So what you can do is, first, the easiest thing is to first check to see, is it arithmetic or geometric? So does it fit into one of these categories? So with 100, am I adding anything to this? 100 minus 40 or minus 60, no. So let's check geometric. Am I dividing by something? 100 divided by, let's see, is this have a, well, let's look and see for a common rate. So 40 over 100 would be 2/5, and 40 or 16 over 40, if I divide by 4, is 4 over 10. Oh, 2/5. Ah, ha, ha, ha. Okay, so the first term is 100. And now from here, every subsequent term, we're going to take the previous term, so a to the n minus 1, and we're going to multiply it, and so I'm going to move it so that it actually looks like that and has the rate in front of it. And we're going to multiply by 2/5 times the previous term. All right? On this one, I think the arithmetic ones are sometimes easier to see because 8 plus 20 is 28, 28 plus 20 plus 20 plus 20. So in this case, we're going to have this type. And you don't necessarily, I mean, you can memorize these, but actually it's, you probably will recognize how to just put them in there. But yeah, if you want to memorize those, have those in your notes, that'd be good. So the first term is 8. And then every term after that is going to be the previous term, so the n minus 1 term, plus, in this case, we're adding 20 each time, so plus 20. All right, because that's the common distance between. All right, now the sequences don't always fit into one of those two categories. Sometimes we have special sequences where, like in this case, we're not multiplying by something and we're not adding the same thing. But if you look at this one, if we start out with -10 and then 8, after this, if we take 8 minus the -10, we get 18. And if we take 18 minus 8, we get 10. And if we take 10 minus 18, we get -8. -8 minus 10 gives us -18. I think we found our sequence. Now we have to figure out, well, it doesn't fit into one of those categories. Well, let's just write it as a recursive rule. So we have to start out with the first two. So the first term is -10, and the second term is 8. So sometimes you have to start with more than one, and that's okay, because what we're going to do then is we're going to say, well, after the second term, thereafter, what we're going to do is we're going to take, to get this next term, we're going to take the previous term minus the term that's 2 previous, 1, 2. All right? So n minus 1 is the term just before that, the previous term. N minus 2 is going to be the one before that one. All right? The one before the one before. Got it? All right. So sometimes you'll just have to get creative in how you put the different terms together, and I think that you will be good at this. I think you guys are going to be really good at this. All right. In this last one, let's try again. So we've got, in this case, we're taking the initial is just 1. That's easy. And now what we've done is we've taken, let's see, we've taken the first term. Oh, you know what this is? This is the first term divided by your, so you take, let's see. You take the term you're in. No, you take the previous term and you divide it by the number that you're in. Because look at this. So we start with 1, and then this one is, let me use a different color so you can see what I'm doing. So the second term is going to be 1 divided by 2, which is 1/2. The third term is going to be 1/2, divided by 3. And 1/2 divided by 3, you're going to flip and multiply, would be 1/6. And then to get your fourth term, you would take the 1/6 divided by 4, or multiplied by 1/4, which is 1/24. The fifth term is going to be 1/24 divided by 5, because it's the fifth term, or times 1/5, which is 1/120. All right. So some of them are going to take some creativity and thinking. And how is one related to the next one? Okay. All right, here we go. Let's keep moving. I got a couple more things. One is, of course, a word problem. Let's see what we got here. So now a mosquito population, now this is in a laboratory where they can monitor how many mosquitoes. This is not the wilds of Alaska. We've got a mosquito population, and they know in this laboratory they've got 500 mosquitoes. Now they know that each day 100 more mosquitoes hatch. Yuck. They also know that in this environment with the pesticides and whatever else, the weather and whatever's going on, each day the population decreases by 85%. So we want to know a recursive rule. So what's happening is this. We're going to start out with an initial amount of 500. That's easy. And then what we're going to do is we're going to say, well, if it decreases by 85%, then what you actually have is 15%. Do you understand the difference there? So it's not, we don't care what's not here. We want to know what is here. So 15% are left. So what you're going to do is you're going to take the previous day. So you're going to take the previous day times 0.15. All right. So 0.15 times the previous one. And then you're also going to add 100 to that. All right, so now that's your recursive rule. You're going to have 0.15 times the previous plus 100. Now, in order to get, so the second part is, okay, well, after 5 days, what's happening? And this is the type of thing that scientists actually really do care about. So this is a real life problem. All right. So after 5 days, what is the population? And then how does that describe? So describe what's happening to the mosquito population in this controlled environment. So what you'll need to do is you'll need to know the first, second, third, fourth. You need up to the fifth. Okay. Because remember, we can't just plug in 5 because we don't know what 4 is, okay? So we've got to put in A1 is 500. A2 is going to be 0.15 times the 500, and do that on your calculator quick. You should get, I believe, 75. So 75 plus 100 is 175. Now if you take A2, 175, and plug it in. So 175 times 0.15 is 26. And 26 plus 100 is 126. And then take the 126 and plug it in times 0.15. You should round it to 19. And when you add to 100, 119. And then put the 119 in and take that times 0.15. You should get 18, and add 100 is 118. And so when it says, okay, now describe the population, it looks to be that, it looks like what I would say is that the population decreases quickly and then it approaches 118. And it's probably going to hover right around 118. It's going to taper off there because it tapered off so quickly here. All right. That'd be nice to be able to taper off the mosquito population. That's great. Okay, one last thing. Here we go. This is the last thing. Iteration is the last thing we're going to do. And this is kind of what we were doing with these recurring sequences. We have to put what we get back in and then come up with a new answer and put that back in. That's what an iteration is. An iteration is a repeated function of itself. So it's the function of a function. And it could be a function of a function of a function of a function. What that means is you're going to take the function of whatever value you get and get an answer. And then you're going to take that answer and put it right back into the new answer and put it right back into the function. I'll show you what I mean. It's really quick and easy. So what I want is the first 3 iterates, x sub 1, x sub 2, and x sub 3 of the function 5x minus 3 if my initial amount, that's what this x sub 0 means, the initial amount. I want to start out with this. In this case, I'm starting out with 1. It's not always going to start out with 1. All right, they're going to have to give you an initial amount. So if the initial amount is 1, then the first iteration is going to be put the 1 in for x and you're going to have 5 times 1 minus 3. So 5 minus 3 is 2. So the first iteration is 2. So to get the second iteration, we would take the 2 and put that in for x, back into our original function. So 5 times 2 is 10, and 10 minus 3 is 7. Now, don't get complacent because, oh, look, 1, 2. Check this out. And it's not always going to be 1 and 2. All right, so now you're going to take the previous number that you got from number 2, and you're going to put that back in. So now you have 5 times 7 minus 3. So now you have 5 times 7 is 35, minus 3 is 32. So the first 3 iterations are 2, 7, 32. All right? Not so hard. You can do it. I have faith in you. All right, see you later.